Hello guys, in this video we are doing acids and bases question which reads as follows. 8.1. Two reactions of sulfuric acid are shown in the diagram below. We have reaction 1 and reaction 2. Reaction 1 is H2SO4, that is sulfuric acid, is reacting with sodium hydroxide to form salt, X plus product Y. Then reaction 2, it's sulfuric acid reacting with water to form ampholyte plus hydronium ions, which is H3O+. 8.1.1, define a low-Bronsted base. Low-Bronsted base is defined as the proton acceptor. The proton that we mean in acids and bases is the H plus ion. 8.1.2, write down a balanced reaction for reaction 1. Reaction 1 is when sulfuric acid reacts with sodium hydroxide to form salt and water. So water will be the product Y. So that is going to be H2SO4 plus sodium hydroxide, then will be formed. The trick about these equations is that you need to know the ions that are present in each compound. Ions present in sulfuric acid are the H plus and the sulfate ions, that is SO4 2 minus. Then ions present in sodium hydroxide are sodium ions and the hydroxide ions. So the positive ion of this species will react with the negative ion of this one. Then the negative for this side will react with that one. The sulfate ion is a 2 minus charge, so that is going to be sulfate ion reacting with sodium ion. So that will be sodium plus reacting with SO4 2 minus. So these superscripts are going to change to be the subscripts. This one will come here. Plus, there is a plus 1 there. Then 2 minus, we ignore the charges. So that is going to be sodium, then a 2 here, SO4. So this is the structure of our sodium sulfate salt that is going to be formed. Then plus a water molecule. Water molecule is due to hydrogen and the hydroxide ions that are going to combine together to form H2O. Then we need to balance our reaction. We have 2 hydrogens plus 1, that's 3 on our left hand side. Then this side we have 2 hydrogens. Okay, it's not balanced. So let's balance the sodiums. We have 2 sodiums here. This side we have 1, so we can balance it with a 2 like that. Then now we have 2 sodiums. We have oxygens is 4 plus 2. We have 6 oxygens. Then hydrogens we have 2 plus 2, that's 4. So let's make a 2 here. Then now we have 4 hydrogens. The oxygens are 4 plus 2, that's 6. Now our equation is balanced. 8.1.3, write down the name of salt represented by X. So the salt that we are going to form, we said it's sodium sulfate. You just need to write it in words. That is 8.1.4, write down the formula of ampholyte A. Ampholyte, what is an ampholyte? It's a substance that can act as both an acid and a base. In the presence of a base, it will be an acid. In the presence of an acid, it will be a base. So that's how an ampholyte behaves. So in this case, we are reacting, reaction 2 is reaction between sulfuric acid plus water to form ampholyte A plus hydronium ion. What we can see is that the hydronium ion comes from water. So meaning water have accepted 1 proton to become H3O+. And this sulfuric acid have lost 1 proton to water. So if it loses 1 proton, meaning 1 hydrogen is gone. So we'll be left with 1 hydrogen and the SO4. Since 1 positive charge is gone, it will remain negatively charged. So the ampholyte A that is formed there is HSO4 minus. 8.1.5. Write down the formula of 2 conjugate acid-base pairs in reaction 2. So in reaction 2, we are saying sulfuric acid have lost 1 proton to become ampholyte A. So that is going to form a conjugate acid-base pair. So the first conjugate acid-base pair is H2SO4 and the HSO4 minus. Then the other one, water accepts 1 proton from sulfuric acid to become H3O+, which we can call a hydronium ion. So water and hydronium ion is going to form a conjugate acid-base pair. So that's H2O and H3O+. Let us go to question 8.2, which reads, a solution of sodium hydroxide is prepared by dissolving 6 grams of sodium hydroxide in 500 cubic centimeters of water. This solution reacts completely with 10 grams of impure ammonium chloride according to the equation below. So we are given the equation of sodium hydroxide plus ammonium chloride to form sodium chloride plus water plus ammonia. 8.2.1, calculate the concentration of sodium hydroxide solution. So on our question, the first part of the question here is going to answer 8.2.1 because we are given the mass of sodium hydroxide. So from the mass of sodium hydroxide, we can calculate the number of moles present in 6 grams of sodium hydroxide. So number of moles of sodium hydroxide will be equal to, we're going to use the formula mass over molar mass. Some they call it MR like that, which means relative molecular mass. So that is going to be our mass, it's 6 grams divided by the molar mass of sodium hydroxide. Sodium is 23 plus oxygen 16 plus hydrogen 1. Then we can punch it on the calculator. This will give us 0.15 moles. Okay, after getting the moles, we are given the volume of water where it was added. Then now we want to know the concentration. Concentration in chemistry can be represented by square brackets like this. So if you want to say concentration of sodium hydroxide, we can say sodium hydroxide inside the square brackets. It means concentration of sodium hydroxide. So that is going to be number of moles over volume. That's the formula. But our volume, it should be in cubic decimeters. So we need to convert 500 cubic decimeters to cubic meters. We can only do that by dividing by 1000. So that is going to be 500 cubic centimeters divided by 1000. We are going to get 0.5 cubic decimeters. That's our volume that we are going to use on our calculation of concentration. So that is going to be 0.15 divided by 0.5. This gives us 0.3 mole per cubic decimeter. Next question, 8.2.2. Calculate the percentage impurities in ammonium chloride. So in this case, we are told that this solution reacts completely with 10 grams of impure ammonium chloride according to the equation below. Ammonium chloride is 10 grams, but it has impurities, meaning impurities are not going to react with sodium hydroxide. So on these 10 grams, there's a certain mass that is going to react, which is for pure ammonium chloride. So in this case, we want to calculate the number of moles of ammonium chloride that are going to react with sodium hydroxide. And our number of moles of sodium hydroxide is 0.15. So we want to see how many moles of ammonium chloride are going to react with 0.15 moles. And as we can see, sodium hydroxide is to ammonium chloride are in the ratio 1:1. So meaning number of moles of sodium hydroxide is equal to number of moles of ammonium chloride. So number of moles of ammonium chloride is going to be equal to the same number of moles of sodium hydroxide, which is 0.15 moles. Then from there, we can calculate the mass of ammonium chloride that reacted. That is going to be number of moles times molar mass. Number of moles, which is 0.15, multiplied by its molar mass. The molar mass of ammonium chloride is 14 and plus 4 hydrogens. Each hydrogen is 1. So that's when 1 times 4 we get 4. Plus mass of chlorine, which is 35.5. This is going to give us 8.025 grams. This is the mass of ammonium chloride that reacted. Let me just say react in short. So now we want to see how much impurities are present. So as you can see, our mass is failing to reach 10 grams of impure ammonium. Why? Is because there are impurities. So the remaining mass that is in this 10 gram is impurities. So mass of impurities, I'll just say M impurities to represent mass of impurities. That is going to be total mass, that is 10 grams minus the reacted one, 8.025. This is going to give us 1.975 grams. After getting the mass of impurities, now I want to see the percentage impurities. That is going to be mass of impurities over the total mass. multiplied by 100. The mass of impurities, that is 1,975, over the total mass with 10 grams and multiplied by 100. This is going to give us 19.75%. If it was percentage purity, we're going to use this mass, which is 8,025 over the total mass. That will be the percentage purity. But in this case, the question have asked us to calculate percentage impurity. Thank you guys for watching this video.